Welcome to all. Today we are going to see the divergence theorem problems. So problem, check the divergence theorem for the field B equal to 4x ax minus 2y square plus z cube az at the point of x equal to 0 and x equal to 1, y equal to 0, y equal to 2, z equal to 0, z equal to 4. Now we are going to find the solution for this. So first we write the divergence theorem. So in a closed surface integral, d dot ds is equal to volume integral of del dot d into dv. So here the vector is b. So we can rewrite s d b dot ds is equal to volume integral of del dot d into del dot b into dv. Okay, next, so here this is our Cartesian coordinate system, Cartesian coordinate system vectors ax, ay, az. So our dv value for Cartesian coordinate is dv equal to dx dy dz. Then del dot b, so del value is dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az into our problem 4x ax minus 2y square ay plus z cube az. Okay, so according to the dot product we can write the equation dou by dou x into 4x plus dou by dou y into minus 2y square plus dou by dou z 4z z cube. So we very well known dot product ax dot ax equal to 1, ay dot ay equal to 1, az dot az equal to 1, otherwise all are 0. So here we are doing partial differential equation, we get 4 because dou x by dou x it gives 1. Next is minus 2 is constant, so we are doing partial differential equation, dou y square divided by dou y is 2y. Then here z cube, so dou z cube divided by dou z it gives 3z square. So 4 minus 4y plus 3z square, that is our del dot b. Next we must integrate with the dv. We very well known dv is equal to dx dy dz. So substitute the value, volume integral of del dot b into dv is equal to integral of triple integral, because we have a dx dy dz. So 4 minus 4y plus 3z square into a dx dy dz. So what is the limits of x, y, z? 0 to 1, 0 to 2, 0 to 4. Apply here 0 to 1, 0 to 2, 0 to 4. 0 to 1, 0 to 2, 0 to 4. So next value is, next we do the integration, integral 0 to 4, 0 to 2, 0 to 1. So what is our value? What is our and 4 minus 4y plus 3z square. 4 minus 4y plus 3z square dx dy dz. So first integrate with respect to x, we get 0 to 4, 0 to 2. So 4x minus 4xy plus 3xz square. Okay. Limit x limit is 0 to 1 dy dz. So substitute x equal to upper limit 1, lower limit 0. We get 0 to 2. 4 upper limit 1, lower limit 0, minus 4, 1 minus 0 y plus 3 into 1 minus 0 z square dy dz. Next 0 to 4, 0 to 2, 4 into 1, 4 minus 4 into 1 into y, 4y plus 3z square dy dz. Next we do the integration with the dy. 0 to 4 we get 4y minus 4y square by z 2 because here y. So we integrate with y, we get y square plus 3z square y. Limit is 0 to 2 dz. So apply the limit 0 to 4, 4, 2 minus 0, here cancel, minus 2, 2 square minus 0 square plus 3z square 2 minus 0 into dz. Next step 0 to 4, we get 2 minus 0, answer is 2. So 4 into 2, 8 minus 2. 2 square 4, 4 minus 0, 4. So 2 into 4 plus 3 into 2. 2 minus 0, we get 2. Z square dz. Next final dz integration. So we get 8z minus 8z plus 6 z cube by 3. Limit is 0 to 4. So we get 2. So apply the limit 8, 4 minus 0 minus 8, 4 minus 0 plus 2 into 4 cube minus 0 cube. So here answer is 32. 8 into 4 32 minus 8 into 4 32 plus 2 into 4 cube, answer is 64. 64 minus 0, it gives 64 only. So 32 32 0, 2 into 64 128. So the value of volume integral of del dot B into dV is 128. This is RHS. Next we prove the LHS side. So what is LHS side? Integral surface of B dot ds. Okay, B dot ds. So for that we must draw the diagram. Here Cartesian coordinates. So x, y, z. So x range is 0 to 1. Y range is 0 to, see the previous level, 0 to 2, and z is 0 to 4. So y is 0 to 2 and z is 4. So we can connect these dots. We get a parallelogram 3D parallelogram. This is called parallel piped. So here one is see this side is in minus ax, this side is plus ax. Similarly we have a 6 pages, so one side is minus az and another side is plus az. One side is plus ay and another side is minus ay. So apply here. So first one is integral, surface integral of b dot ds. So we very well known Cartesian coordinates ds values. It has 3 ds. dsx value is dx, dy dz into ax. dsy is equal to dx dz ay. dsz is equal to dx dy into az. So it can be write it in first b dot dsx plus b dot dsy plus b dot dsz. Okay, first we find the b dot dsx. b dot dsx is equal to first what is b, we must write the b value here. What is b? 4x ax minus 2y square ay plus z cube az. 4x ax minus 2y square ay plus z cube az into here b dot dsx. What is dsx? dy dz dot ax. dy dz ax. So according to the dot product we get only the x value. So 4x dy dz. Okay, so b dot dsx is equal to 4x dy 4x dy dz. So substitute in this, we have two values, x equal to 0 and x equal to 1. Okay, so surface integral of b dot ds x is equal to integral, here integral value is dy dz, y value is 0 to 2, z value is 0 to 4. So 4x dy dz. Okay, so next is 4 integral of 0 to 4, 0 to 2, 4x dy dz. So we get in the first we are substituting y value, we get 0 to 4, 4x y 0 to 2 dz. Next is integrate with respect to z, 4x y is 0 to 2 and z is 0 to 4. This is our surface integral of b dot dsx. Okay, so here x have two values, one is x equal to 0 and another is x equal to 1. So consider in ax, in x equal to 1, ax is normal positive sign, x equal to 0, ax is minus ax. Okay, so substitute the value here, 4 into 0, anything into 0 we get a y equal to 0 to 2, z equal to 0 to 4, it is 0. For x equal to 1, what we get? 4, 1, y value substitute y equal to 0 to 2, z equal to 0 to 4. So 4 into 1, limit substitution 2, 4 minus 0. So 4 into 2 into 4, it gives 32. So integral, surface integral of b dot dsx, it gives 32. Next is surface integral of b dot dsy. So first, what is b? See here, 4x ax minus 2y square ay plus z cube ax. 4x ax minus 2y square ay plus z cube az into here dsy. So what is the formula of dsy? dx a dz ay. So dx dot dx dz ay. So according to the dot product we get only ay dot ay equal to 1, otherwise all are 0. So surface integral of minus 2y square dx dz only. Okay, then y have a two values, y equal to 0, y equal to 2. So substitute the limit of dx and dz. So x limit is 0 to 1, z limit is 0 to 4. Okay, minus 2y square dx dz. Already I told y equal to 2 at place, it gives a plus ay. Y equal to 0, it gives minus ay. So here integral 0 to 4, integral 0 to 1 minus 2y integral 0 to 4, integral 0 to 1 minus 2y square dx dz. So it gives minus 2y square is common, x 0 to 1 and z 0 to 4. So minus 2y square, 1 minus 0, 4 minus 0. It gives 2y minus 2y square, 1 into 4. So here we apply two values of y. Y equal to 0 means it values 0. Y equal to 2 means minus 2, 2 square into 4. So minus 2, 4 into 4, so minus 32. So integral s into b dot dsy is equal to minus 32. So the final one is s into b dot dsz. So what is b? Very well known, 4x ax minus 2y square ay plus z cube az dot, what is dsz? dx dy into az. So next is surface integral. According to the dot product we get only z cube dx dy. Okay, so z equal to 0 to 4. So here is az, here minus az. Okay, so apply the limit of x 0 to 1, y is 0 to 2, z cube dx dy. So we get integrate z cube, x equal to 0 to 1, y equal to 0 to 2. So z cube 1 minus 0, 2 minus 0. So z cube 2. So substitute z values here. So z equal to 0 and z equal to 4. So here 2z cube. So answer is z equal to 0, we get 0. Z equal to 4, we get 2 into 4 cube. So answer is 2 into 4 cube, 64. That means 128. So here we sum up all the values. Integral s b dot dsx plus integral s b dot dsy plus integral s b dot dsz. Okay, so what is b dot ds? It gives 32. b dot dsy, it gives minus 32. b dot s ds is equal to, it gives 128. So 32 minus 32 plus 128, it gives 128. The overall of s b dot ds. So what is our divergence theorem? Integral s b dot ds is equal to integral v del dot b into dv. So what is b dot ds value? 128 is equal to, what is b dot dv value? 128. So 128. So both are equal, hence divergence theorem proved. Okay, thank you.